This is Unit 12, Statistics, Normal Distribution, video number 2. And we left off talking about this question number 19. While I was offline, I entered the data into my TI Nspire software so we can get the information out. And the next big thing that we're going to talk about is continuation of this 68, 95, 99.7 rule. And then if we have time in this video, we will move into discussing how to change from percentiles to scores instead of just scores to percentages. So let's take a look at what the TI Nspire has to say for us. So here's my information. I have a new page to run my 1-var stats on. So 6 for statistics, 1 for stat calculations, 1-var stats. Our X list, if you saw it, was exam scores. It's the only thing I have in so far. And we got our information back. We have our mean, which is 79.7. Easier to type, I guess. 79.7. And then our standard deviation, which was population standard deviation 8.706. Here equals 8.706. Now, what does it mean that we're looking for? Determine what percent of the students scored within 1 standard deviation of the mean. So that means within 1 standard deviation of the mean, I've got to take this 79.7 and add our 8.7, and we are going to get 88.4. And if I take 79.7 and subtract 8.7, I'm going to get 71. So now I need to see how many scores are in that range. So how many scores are between 71 and 88.4? Nope, nope. So no, no, yes, no, yes, 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 yes. 73, yes. 74, yes. 79, yes. 86, yes. 82, yes. 90, no. 92, no. 93, no. And 73, yes. So now we need to figure out how many scores we have left. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 scores out of 20. And that gives us 65% of the scores are within that range. So do you think the results of the examination show an approximately normal distribution? And we could say yes, because 65% of the scores are within, oops, we're covering up here, within, well, what happened? Within 1 standard deviation of the mean, and in the other case of a normal distribution has 68.4% of the scores within 1 standard deviation. So we are approximately normal. And so what number would make it not approximately normal? I wouldn't go much further outside of the 65 range. Anything between 65 to 70 would be approximately normal. If you get down to 60, you're not really normal. If you get up to 75, you're not really normal. So any value between 65 and 70 would justify that you have an approximately normal distribution. Okay, so now to move on to the next topic. This is more of the same. A set of test scores is distributed normal with a mean of 70 and a standard deviation of 6. Between what two scores could 68% of the scores lie? So you have to know that that is 1 standard deviation. You would do 70 plus 6, which is 76. 70 minus 6, which is 74. And so, or sorry, 64. So it would be between 64 and 76. And you need to show a little bit of work because This would be a show your work kind of question. So you might want to say 68% means 1 standard deviation on each side of the mean. And then you could just come up with that. Okay, so that's kind of how you go through these. These percentiles, remember percentile is to a specific part of the curve. So hold on, one page I did not bring the curve to. I'm just going to copy and paste it over here. When I do that, I'm going to cover up a lot of information, so I'm going to put it right here. And we are saying 100 pipes have a normal distribution with a mean of 102.4 and a standard deviation of 0.2. If one pipe measures exactly 102.1, it lies where? So if it's 102.4 is right here. There's one right next to it. So your 102.4 is right here. And they are saying 1 standard deviation is going to be over here. 1 standard deviation away would be down 0.2, so that would be 102.2. And if you're going to go down another half a standard, this one over here would be another full standard deviation away, which would be 102.0. So if you're 102.1, you're exactly halfway between here. So you're at this spot right here. So what percentage is to the left of that? And it's 0.1. So we're going to add it up. We've got 0.1 plus 0.5. I know part of this is off the screen, but it's symmetrical. Then 1.7, and you should be able to look at this if you printed out the reference table yourself, plus 4.4. And if you add all this up, it is below the 16th percentile. Here's one of these bigger explanation questions. Mrs. Ramirez is a real estate broker. Last month, the sale prices of home in her area approximately normal distributed with a mean of 150,000, a standard deviation of 25,000. A house had a sale of 175. What is the percentile ranked to the nearest whole number? So if we are 1 standard deviation above, so we are 1 standard deviation above, so this would be at the 1. I'm going to bring this curve down here. Or I'm hoping to. How do I grab it? Where is it? Oh, I'll just paste it again. So if I bring it down here, and you're at, so if you're doing this, you can always re-sketch the curve onto your paper. So this is 150, 175 is here, and you know that you're going to be going to this value here. So you're going to add everything up to here. You know to the midline is going to be 50%. So you know that this is going to be 50% plus 19.1%. That's not 19.1, 19.1% plus 15.0%. And that is going to give you 84.1%. So that would be to the nearest whole number. That is going to equal 84%. And explain what percentile means. And if you recall from our first video, percentile means that you are 84% from the bottom and 16% from the top. It is your rank in the overall population. And Ms. Ramirez told a customer that most houses sold between here and here, and she is correct because that is within 1 standard deviation of the mean, which is 68% of the population of the houses sold at that amount. So you just really need to understand the curve, understand percentiles, understand how to calculate the percentages. Okay, so we're going to stop here, and in our last video, we are going to discuss the percentiles to score.